Good morning, my name is Javier, and today we're going to review for the GED test. Okay, so if you are getting ready to take this standard test, we are going to study the math section of the test. So now the material that I'm going to review with you is available on the GED website. So I'm going to give you the link in the description below so you can click on it and you can see it if you want to do it, okay? Because even if you want to do it, it's going to be the same material that you are seeing here, okay? So I'm a math teacher and I'm going to proceed to explain these exercises to all of you. I hope it helps, and I will try to be as clear as I can because my goal is to help you out so you can pass your GED test with a good grade, okay? Let's start by solving the first exercise that we have here. Okay, so the first problem says fractions and decimals in order. It says place fractions and decimals in order, so that's what we are going to do in this exercise. And the example question says, between which pair of decimals should 4/7 be placed on a number line? So before starting doing the exercise, I want you to remember that a number line, you have seen it before, is a line, okay? It starts in 0, and you know that on this side you have the negative numbers, and on this side, on the right side, you have the positive numbers. My numbers here, all of the options that I have here are positive, so I'm going to concentrate just on the positive side of the number line, which is the side on the right of 0, okay? So now they are giving me 4/7. 4/7 is the same as if you divide 4 by 7, okay? So now I cannot pull groups of, with 4 I cannot pull any group of 7. 4 doesn't go into 7 because it's smaller than 7. So I'm going to start by placing a 0 here, and that's what we do when we start dividing quantities and the numerator, in this case because we are talking about a fraction, is less than the denominator. Then we need to start placing a 0 here, and we are going to put a decimal point because the result of this division is going to be less than 0. So that's why we need to lead with a 0 here, okay? So now, if I put this 0 here, then now I need to place the 0 here because my goal is to make this number divisible by 7. So how many groups of 7 can I form with 40? Now, if I place here 5, I know that I can pull 5 groups of 7, and that's equal to 35. So 5 by 7 gives me 35, right? And now I'm going to subtract 40 minus 35. So 40 minus 35, that's equal to 5, okay? And now I got to divide 5 by 7. So now I cannot divide 5 by 7, so I have the same situation that I had at the beginning. However, see, because I'm dividing 4/7, now that I know that it's 0.5, what I'm going to do to be able to divide this number by 7, I will place a 0 here, okay? And now, how many groups of 7 can I form with 50? Well, I can form 7 groups. So 7 by 7 gives me 49. And 50 minus 49, that gives me 1 as a reminder, okay? I don't care about the reminder because I care just about the decimals to place my fraction in the number line. So I know if the middle of the line, I'm going to have 0.5 here, and that's 1/2, okay? That's a fraction. But my fraction is equal to 0.57. You can see it here, 0.57. So it has to be to the right of 0.5. So now I'm gonna use another color, and then I'm gonna concentrate on the right of 0.5 because that's where my fraction is. So I have 0.6, 0.7, 0.8, 0.9, and 1. Okay. Let me draw it better. Let me see if I can. Okay, Okay, so I'm gonna do 0.6, 0.7, 0.8, 0.9, and 1. Now, my number is 0.57, so I know it's less than 0.6, which is here, but it's greater than 0.5, which is here. So 0.57 or 4/7 is about around this point over here, okay? So the correct option is between 0.5 and 0.6 because as you can see you have 0.5 here and 0.6 is this point that this point that you have right here, okay? So the correct answer is option C, between 0.5 and 0.6. Okay, so we are going to solve now problem number 2. The problem number 2 is about multiples and factors. For example, then you have here that the least common multiple of 3 and 5 is 15. Why? Because 15 is the least amount that you can get multiplying 5 and 3, right? And then the greatest common factor of 12 and 30 is 6. And I'm gonna pause here a little bit to explain to you better what is the least common multiple and the greatest common factor. So let's make a parenthesis here before we move on. Okay, let's talk first about the least common multiple. In this case, the two numbers that we are going to study are 3 and 5. Why 15 is the least common multiple between 3 and 5? Well, because when you multiply 3 by 5, you get 15, and there is not another number less than 15 that you get when you multiply 3 and 5, right? 10, like 14, 13, 12, none of these numbers can be obtained when you multiply 3 and 5. Therefore, 15 is the least common multiple. Okay, so now let's study the second case, which is the greatest common factor. For this, for this topic, with the two numbers that we are going to study are 12 and 30, right? So let's see which is the greatest common factor between those two numbers and why. So you know, so that when you get 12 is because you multiply two numbers. You can multiply, for example, 2 times 6, that gives you 12, right? And 30, you can get 30 by multiplying 2 times 15, okay? And that's 30. So now let's see which numbers we can decompose here. So 2, we cannot keep decomposing 2, so we bring it down. But then 6 is equal to 3 by 2, okay? 3 by 2 gives you 6. We cannot decompose the 2 in the case of 30, and I'm going to divide them here so you don't get confused. But we can get 15 when we multiply 3 by 5, right? Now, can we keep decomposing these numbers here? I don't think so, because 5 you cannot the only factors of 5 are 5 and 1. The only factors of 3 are 3 and 1. Same case with 2. So now, which are the common numbers between the two of them? As you can see, you have 2 and 3 for 12, and you have 2 and 3 for 30. And because they are multiplying each other, so you got 2 by 3 is equal to 6, and that's why 6 is the greatest common factor between 12 and 30. Okay, so now that we reviewed the least common multiple and the greatest common factor, we are gonna solve this problem. It's a word problem, and it says, Susan and Daphne are participating in a walkathon at the local community college track to raise money. Susan can walk around the track in 4 minutes. Daphne can walk around the track in 6 minutes. Susan and Daphne started walking at the same time. How many minutes will it be until they complete a lap at the same time? So what the problem. So every single time that you are gonna solve a word problem, you need to write or find out what the problem is asking you to find. Okay, so the problem in this case is asking us to find how many minutes will it be until they complete a lap at the same time. So minutes they complete a lap at the same time. Okay, so how are we gonna the two most important questions that we gotta answer in our word problem is what and how, because if we know what we are gonna answer, then we will have an idea how to find what the problem is asking us to find. And if we know how, then we have a plan and we can find the answer to the what. Okay, so now how? Well, I'm gonna draw Susan here in red, and I'm gonna draw Daphne in blue. Okay, so they start walking. Okay, so every single time, so for example, Susan is faster because she can walk the whole thing in 4 minutes. Okay, so in 4 minutes she complete one lap. And I'm gonna put here one lap. 4 minutes more, she completes 2 laps. In 4 minutes more, she completes 3 laps. Right? While Daphne, she's slower. She walks at a slower pace. So she takes 6 minutes. So she takes 4 minutes that plus 2. Okay? So 6 minutes to complete one lap, and then she takes 6 more minutes to complete another lap. Okay, so as you can see, the amount of time that takes Susan to complete three laps is the same amount of time that Daphne takes to complete 2 laps. Okay, so now we can answer the question with this drawing here. So we know that they will take 12 minutes to complete a lap at the same time. Okay, so let's do it now with the factors of the numbers. So I know that Susan, and I'm gonna write it here because I was using colors, so I know Susan takes 4 minutes, and I know that Daphne, she takes 6. So now let's see, which are the factors of 4? 4 can be decomposed as 2 by 2, and 6 can be decomposed as 2 by 3. Okay, so in this case, because we are looking for the multiple, the number that is divisible by both 4 and 6, we wrote the factors of 4, and we wrote the factors of 6. So now, if a number is divisible by 4, we need 2 2's, right? If a number is divisible by 6, we need 1 2 and 1 3. So I'm going to write the factors here so you can see what I'm going to do. So I'm going to say 4 is equal to 2 by 2, so I need 2 2's, and 6 is equal to, and I'm going to write it, let me write it in another color, 6 is equal to 2 by 3. So so if I want the number to be divisible by 4 and 6, I need the factors of both numbers. So I need 2 2's, and I have just one here for 4, and I need 1 3, and I don't have any 3 here. So if I want to make it common for the two of them, because I need 2 2's for 4, I'm going to write 2 by 2, right? And then I have 4 covered, and I need 1 2 and 1 3. So I already have 2's here. As you can see, I already have the 2's, so I'm only missing the 3. So that's what I'm going to write here, 2 by 2 by 3. So the minimum, or the or the minutes that will it be until they complete a lap at the same time is going to be 2 by 2, which is 4 by 3, so that's going to be equal to 12 minutes, okay? And the answer is option C, 12 minutes. 24 by, we have 24 here, but don't get confused because by 24, the problem is asking you, how many minutes will it be until they complete a lap at the same time? 12 is gonna happen before 24. So 12 is the right option here, okay? Option C. Let's review now exercise 3. In this exercise, we are going to simplify exponents. Then we have an example here. It says, simplify numerical expressions with exponents. For example, 2 raised to the power of 6 by 2 raised to the power of 5, and that's equal to 2 raised to the power of 11. So basically, when you are multiplying exponents and then you have the same base, remember, if you have a number, the big number, that's the base, and the small number at the top, this one here, is the exponent. In this case, when you multiply two numbers with exponents and they have the same base, for example, a to the power of 5 by a to the power of 6, then you are going to write the same base, which is a, and then you are going to add the exponents. That's what you got to do there. You don't have to do anything else. So it's going to be a to the power of 11. So now let's see, with that rule, let's see how we can solve the problem that we have here, because here we have 2 to the power of 9, 3 by 3 to the power of 5, and all of this is multiplied by 2 to the power of 4 by 3, right? And this, as you can see here, this here is raised to the power of 2, okay? So I'm gonna erase this. Okay, so remember, we're gonna use here order of operations, PEMDAS, okay? So we're gonna start by solving the parentheses. In this case, we have two parentheses, but I'm gonna start solving this parenthesis here because this parenthesis is raised to the power of 2. This parenthesis here is not raised to any power, but this one, yes. So I'm gonna start by solving. Let me write here the solution. So I'm going to write the whole thing here, 2 raised to the power of 9 by 3 to the power of 5, parentheses, and let me write here by, then I have 2 to the power of 4 by 3, okay, and then I have a parenthesis here, and I have to the power of 2. I told you that I was going to start here, and that's what I'm going to do. So now, another rule of exponents is this one here. This is the first rule that I explained to you, but that's not the only one. And the second rule that I'm going to write here is if you have a base with an exponent, right? Let's see, b to the power of n, and you have, let me correct this here, and then you have that base and exponent raised to another power here, the result is going to be the same base, but then you are going to multiply the exponent. It's going to be m by m, okay? So now we are going to apply that rule to this parenthesis here. So we are going to write the base is 4. We are going to multiply 4 by 2. That's going to be equal to 8. By, because we have this by sign here, 3, this number, when you don't see an exponent at the top of the number, that's a 1 that you have there, okay? You assume automatically, if you don't see it, that is a 1. So in this case, you are going to multiply 1 by 2, so you are going to have 3 to the power of 2. And then you are going to have your parenthesis here, and on this parenthesis, you are going to have, in this parenthesis, sorry, you're going to have 2 to the power of 9 by 3 to the power of 5, okay? Now you are going to multiply everything. Remember, you are going to multiply or apply the property to the base that are the same. So in this case, these two bases are the same, so I'm going to have 2 to the power of 9 by, let me write the x, by 2 to the power of 8, right? And these two bases are the same, 3 and 3 to the power of 5 and 3 to the power of 2. So I'm going to write by 3 to the power of 5 by 3 to the power of 2. Okay, so now I'm gonna apply the rule that I told you at the beginning, because I have bases with I have the same base with different exponents, okay, as you can see here. And then this is the case here. So I have the same base, which is 2, and I'm going to add the exponents. 9 plus 8, that's equal to 17 by, I have another base, which is 3, and I'm going to add the exponents. 5 plus 2 equals 7. So option D is the right choice here. Exercise number 4, we're going to talk about the distance between numbers on a number line, and we're going to remember, and we did that for exercise number 1, I think, if I'm not mistaken. So we're going to review what is the number line. So remember that the number line is a line, and then you have 0 here, okay? You have the positive numbers on the right and the negative numbers on the left. Now, the problem says the points -4 and 5 are plotted on a number line. What is the distance in units between the 2 points? Okay, well, let's plot the points. So we have -4, so we have 0 here. So to the left, we have the negative numbers. So we got -1, -2, -3. We got -4 over here. And we have positive 5. So 5 is located to the right of 0 because it's a positive number. So we're going to plot it here. This is 1, 2, 3, 4, 5. Let's suppose that 5 is over here. So now, what is the distance between the 2 points in units? Well, let's see how many jumps we have to do from -4 to positive 5. So we got 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we need to jump 9 to the right. So the distance between the 2 points is option D, which is 9. Why? Well, because we have 9 spaces between -4 and positive 5. Exercise number 5. This exercise is about whole numbers, fractions, and decimal problems. It says compute and solve problems with whole numbers, fractions, and decimals. And the example question says simplify 12 plus 15 divided by 3 multiplied by 6 minus 4. So I want you to pay attention if you get a question like this on your test. I want you to rewrite what the test is giving you, because the test is not really telling you. I mean, you could use PEMDAS here to solve this exercise, right? So you know that you should start by parentheses, okay? Exponents, then the multiplication, then the division, then the addition, and then the subtraction. In this problem, you can see you don't have any parentheses, any exponents, when you have a multiplication, you have a division, addition, and subtraction. But my suggestion is that you rewrite this so you can see it clearly. So you know that you have 12, right, over here, and then you have a plus sign, so you need to add to 12, you need to add something. So how are you going to add that to 12? Well, you have here a division. You have 15 over 3. So I would write 15 divided by 3, right? Because that's what they say here. And the result of that division, you are going to multiply it by 6, because that's what it says here. And then I'm going to subtract 4, okay? Let's see, now that we have the parentheses, now we know that we should start by solving the parentheses. So we are going to start by solving 15 over 3, and that's equal to 5, okay? So we are going to have now 12 plus, the parentheses gave us 5, right? And we need to multiply that by 6, and we need to subtract 4. Now, we did the parentheses. We don't have exponents, but we have now multiplication. So that's what is next. So we have 12, and we're going to solve the multiplication here. 5 by 6, that gives us 30. So I'm going to write here plus 30 minus 4, okay? So we did the multiplication, is done. So now, do we have any division here? We don't have any division. We had a division here at the beginning, but it was in a parenthesis. So that's why we started with the dividing 15 by 3, because it was inside of parentheses. So 12 plus 30 minus 4, we don't have any division, we have addition. So let's solve 12 plus 30. If you add 12 plus 30, that gives you 42, right? And then you are left with 42 minus 4, and then we did addition, and then we're going to do the last operation, which is subtraction. So 42 minus 4, that gives us 38, and 38, which is option C, is the right answer. Okay.